Okay, good evening, everyone. Welcome to Denver Open Source Users Group Election Edition. I'm Dan Hillenbrand, and my buddy Mike Barker. Also, well, the two of us run this user group, which has been around for about 20 years now. Originally, I think it was the JBoss user group. Anyway, thank you for joining us tonight. We'll be talking. Actually, Michael will be talking about linked data. Michael Carducci has been with us several times before, and I'm sure you'll enjoy him again tonight. So to talk about our sponsors, we've got, let's see, 7 or 8 of them. Jay Zimmerman of No Fluff Just Stuff fame has a lot for us to announce tonight. We've got the December 7th to 10th Architecture Conference, and the DOSEG members will get a discount if you give him an email. And that is in the information in the meetup site tonight. He's also running a super deal for the year-long virtual workshop subscription. He's calling this a flash deal. You see that right on his site, which is nofluffjuststuff.com. Also, we have the 2020 Progressive Web Experience virtual edition coming up November 30th to December 2nd. And Tech Leader Summit is December 3rd and 4th. So he also has special DOSEG pricing available for that. So send him an email at j@nofluffjuststuff.com for details. Oh, and by the way, if you go to his website, you'll see some webinar playbacks. Like every Friday for an hour, he's got some fantastic speakers, including like I saw one from Brian Sutton the other day. So that's kind of an extra free door prize for y'all. If you go to that, you can see some of those recordings and watch them live too on Friday during the day. Okay, agilelearner.com. This is Venkat Subramaniam's deal. Let's see, he's got world-class instructor-led online live classes and also recorded training sessions and presentations for developers. And we do have a 1-year subscription to give away tonight, and I'll put the details on how you can get a chance for that in the comments. Okay, from Apex Systems, we have Braden Collup. Apex calls themselves a world-class technology company with solutions for digital goals. And of course, one of the things they do is recruiting for some of us in the Denver area. Here we go. Oh, sorry, I'm reading this unprepared. So anyway, I talked to Braden today, and they currently have multiple software engineering openings, including Java and Spring Boot roles, C# and Angular roles, Python cloud roles, and data engineering roles. So go ahead and get a hold of him at bcollup@apexsystems.com. Again, that should be in our meetup page. Okay, we have PeerSource, also a recruiting firm. Caroline Danielson is our representative from there, and they also recruit for technical sales and accounting services all 50 states. They are hiring across the country and have some remote openings, so give Caroline a message to see what they've got there. Okay, Okta, which I always try to say Okta. Okay, Matt Rabel is behind the scenes tonight. Okta, everything you need to build or integrate authentication and user management. So thank you, Matt, for doing this work on the video for us. Skill Distillery, where we used to meet and hopefully we'll again meet for our in-person meetings. They are an immersive hands-on program where you learn the critical coding skills to build a lasting career, not only as a web developer, but as a full-stack Java application developer. And I can tell you, I've worked with some of these people that graduate from there, and they really know their stuff. So if you're interested in getting, learning this from the grounds up, or if you know someone who wants to do that right, definitely give them a call. And they do have a referral program where you can earn $250. So get in contact with me personally, or go to skilldistillery.com/refer for that information. Okay, finally, our last sponsor is JetBrains, and we will be giving away one JetBrains Toolbox license tonight. And again, I'll put the information on how you can sign up for that. Okay. So getting close to our featured speaker, Michael Carducci, will be here tonight talking about linked data. And I think I'll have to let Michael take over from here. But it's actually been around for a while, but it's starting to catch steam. And I guess we'll let Michael give us the talk.
All right. Dan, thank you so much for the introduction. And yes, everybody on the stream, my name is Michael Carducci. I am a hands-on software architect. I am a passionate speaker and sometime doer of the impossible. But I want to thank everybody who's on the stream right now for taking the time to join us on this, a random Tuesday where nobody is at all distracted and nothing interesting or concerning or whatever is going on right now at all. So regardless of your positions, if you have anxiety about what's going on today, well, let me take you away from that. We're going to talk about something exciting instead. So let's jump right into here. And so we're going to talk about linked data. And as Dan mentioned, it is nothing new. In fact, some of these ideas have been around for over 2 decades. And I think it's partially true that these ideas are starting to gather a lot of momentum, but we're also kind of reaching a level of maturity and we're reaching a point in what we're doing that all of this becomes very, very relevant. And so really what we're going to talk about, this is kind of falls into the category of what I call a big idea talk, right? I'm going to try to introduce some context and give you some of the concepts and give you the context behind them and why this is important and kind of give you a few pointers to go from here. So let's dive right in. And once again, for those don't know me, Michael Carducci Carey, depending on how you know me. And again, I spend my days as a hands-on software architect. I work for a company called IHS Markit. And actually, if you're interested in working on a greenfield project at the cutting edge of machine learning, artificial intelligence, the semantic web, and a whole lot more, hit me up because we are hiring. But generally, for those who know me, depending on where you know me from, you'll know one thing, that I sort of live at the intersection between magic and technology. And I'm not really exactly sure what that makes me, but it makes me something. And it's an exciting place to be. And I'm going to take you on a little journey into that place right now. But to get to what we're talking about, I want to start from here, from a little bit of reflection, from a moment of gratitude, because I've been extraordinarily lucky at least 3 times in my life. When I look back over the last 40 years, 3 times I've been insanely lucky, just right place, right time, everything just lined up, and these little seemingly random moments changed the course of my entire life. Now, the first one of these lucky moments was back in 1986. And in fact, a particular day in 1986, it was the last day of the Sweetwater County Library discard sale. Now, I grew up in a fairly modest household when I was very young, and of course, my parents, like any parents, they wanted to give us as many advantages as they possibly could, and there weren't many that my folks could give me, but they wanted to make sure that we had books in the house. So we were regular patrons of the library, and we always participated in the discard sale. But again, being a modest household, we could only really go on the last day of the discard sale. And on the very last day of the discard sale, $1 would buy you a very large paper bag. Now, this paper bag was kind of a big size grocery bag. And for $1, as many books as you could stuff in that bag, you could leave with them. And so I wandered around and grabbed all sorts of colorful and curious looking books, but I grabbed this one on a whim. This book launched a journey that took me around the world. It put me on TV, film, and radio. The effectively 5 cents that I paid for this book ultimately gave me a gross ROI of well over $1 million in performance fees. This book also was responsible for launching my career in technology, my career as a developer, and in a very real sense, this book is why I'm here today. The most random, inconsequential decision set a course for my entire life, and it's been a wild journey. Now, the second lucky thing that happened was back in 1998. I was on a double-decker bus somewhere in Kensington in London. And I was on the way to the magic shop, I should point out. And on that bus, I was standing there. There were no seats available. I lost my balance and I fell in this young lady's lap. And to be honest, at that point, we started talking. I forgot all about the magic shop and I spent the day with her instead. And I got to tell you, she was really something. Beautiful, charming, devastatingly intelligent. And we spent the whole day together. And it was an amazing day that I will never forget. Of course, it really is a shame that she and I lost touch all those years ago. Although we did happen to reconnect a few years ago and got married in New Orleans last year. So with or without this postscript, I still consider that one of the luckiest things that's happened in my life. But the third lucky thing was I had the opportunity to grow up in this house, in this town, in this state. Now, depending on how well traveled you are, folks might ask, well, what's lucky about Wyoming? And there are different perspectives on this. To be fair, there are things to love about this state, but to some outsiders or people who live there, they can be hard to spot. In fact, comedian John Oliver had this to say about Wyoming.
That's practically an entire Wyoming disappearing into thin air. That is really bad. Unless, of course, it's the actual Wyoming disappearing, in which case it really might be for the best. It's a semi-arid sandbox filled with fluffy cows and nothing. The most famous part of Wyoming is the state trying to swallow itself up. And the second most famous part is it spitting itself out again. It's clear that even you don't like you, Wyoming, and it's getting hard for the rest of us to watch. And to be fair,
I think we lost your audio, Michael.
Oh, thank you. Now, of course, John Oliver has caught some flack over the years for insulting random municipalities around the country from time to time. I can tell you this, as somebody born and raised in Wyoming, I can speak for myself. I can speak for a lot of people I know, maybe not everybody, but a lot of us are just grateful to have been noticed. Regardless, in that semi-arid sandbox full of fluffy cows and nothing, something was happening. And that something was the National School Network testbed. So this NSF net that used to be called the ARPA net that connected universities and research institutions for about half a decade, where they were just about to have K through 12 schools connected as well. And Jim Rogers here was one of the visionaries that kind of pushed this and led this initiative in the small town of Green River. And in fact, Green River was the foundation of the National School Network testbed and was the very first school district in the country to connect to the internet. Now, if you're anything like me, you're thinking, wait, this town, an oasis of about 8,000 people in a high desert wasteland, this town that is largely just a lingering vestige of the Transcontinental Railroad, this town that is so wild that the infinitely unflappable Phileas Fogg, when he stopped briefly there in his 80-day trip around the globe, and throughout the entire novel, Fogg maintained his legendary implacable calm, but just 5 minutes in Green River, he was ready to kill someone. Yes, this town and all of the residents therein were present for the dawn of the information age. And the visionary behind it, this guy, happened to live here. My next door neighbor, my first mentor, and just, again, insanely lucky. But the point is, I had a front row seat to the revolution that is the web. I was there from the very beginning of the web, and you will have a front row seat to the next revolution. But maybe I'm overselling this. So let's actually look at this revolution for a moment. See, by 1989, we were on the brink of having access to untold amounts of information. And, for example, if you were conducting an experiment at CERN in Switzerland, you could benefit from the results of simultaneous research happening on the other side of the planet instantly. The problem was, who's doing this research? Who's doing what research? Where is the research taking place? When was it added? How do you access it? See, back in those days, the dominant application protocol was Telnet, meaning you'd have to connect into a custom app on a server, hosting its own custom information system with its own commands and quirks, with its own methods of organizing information. Oh, you need to look somewhere else? Well, that was a PDP-11, and this is a VAX, so everything is different. We needed to standardize. And in fact, a computer scientist at CERN, Sir Tim Berners-Lee, saw the potential of taking existing technologies and putting them together in a standardized way to give us access to this information. And in fact, he says the problems of information loss may be particularly acute at CERN, but in this case, as in certain others, CERN is a model in miniature for the rest of the world in a few years' time. CERN meets now some problems the rest of the world will have to face soon. And maybe in 10 years, there's going to be a solution, but we need something today. He realized that there was so much valuable information that was just out of reach. And it was a problem that just wasn't going to go away. And so this memo was written in 1989, and it took a little bit of time to gather steam. And in fact, 4 years later, in 1993, there were just 50 web servers. And by 1995, there were millions, and we had behemoths like Yahoo, like eBay, even Amazon. And today, we have self-driving cars. We have light bulbs that obey our commands. We have continuous revolutions in science and technology, and we have access to the sum total of all human knowledge in our pockets. We're connected to all of this constantly on a 10 gigabit ubiquitous wireless network, and we literally have robots to clean up after us. And I threw this in here as a joke, but yeah, we literally have robots cleaning up after us now. So how do we come so far so fast? The answer is that information made this possible. Think about it this way. You're working on whatever you're working on, and you get a rather nasty stack trace. You've got an error. What do? Do you read this? Do you start building a little test harness application to kind of probe at it? No. You ask the entire world, hey, I got this error. What does it mean? And this is an actual question. I got it random from Stack Overflow. And so this person asked this question about native C libraries and Android Studio, developer in Pittsburgh, Pennsylvania. And less than an hour later, another developer who just happens to be a Google developer expert living in Paris answered. And this is an exciting time to be alive. But I want to point this out. I learned to program here. I didn't have Stack Overflow. I couldn't ask every developer on the planet. If I ran into a problem, I had to figure it out. I mean, I had a few things at my disposal. I owned maybe 2 or 3 books. I could ask my neighbor, but that was about it. There was no shortcut. And what's funny is we romanticize this. Back when programmers were real programmers. And, there's a point. There was a time when programmers were, quote unquote, real programmers, when there was nobody to ask, when every single problem had to be solved the hard way. I love this quote. How did you know so much about computers back then? I didn't. It was the first one. But fortunately, we are beyond this point now. And as a result, we get to stand on the shoulders of giants. And it's easy to get occasional imposter syndrome because I don't even know if I could still program under the constraints that I was programming under in the late 80s and early 90s. I don't think so. Like Stack Overflow and search engines and everything are so integral into my workflow. But does it matter? Because something really powerful happened with all of this, right? You see this again and again and again. You saved me weeks. You saved me weeks of struggle. You saved me days of headaches. You saved me days. You saved me hours. You saved me months. And I remember those times when you'd run into a problem and it would take days of trial and error and experimentation before you finally figured out there was a bug in this particular library, and then you had to figure out how to work around it. So let's do some back of the napkin math. Stack Overflow has been around for about 10 years, and in an average month, they get 262.1 million monthly visits. Now, obviously, it wasn't always this high, so let's be generous with the next stat. Let's assume that only 40% of those visits find one answer to a question on their visit. And let's also cautiously assume that it's going to save them about 4 hours. Now, I've gotten answers that have saved me minutes. I've gotten answers that have saved me days. I think 4 is a pretty safe amount of time to save just by finding the answer to a question or getting the root cause of an error or something like that. Now, you add that up, that's 12.5 billion questions answered. 50 billion hours saved. What is that in real terms? 5.744 million developer years. 5.7 million years of doing this instead of doing this. The difference is information and access to information. And in fact, Sir Tim Berners-Lee so masterfully solved the problems with a mesh of information that we don't even think about it. If we need to access a document on the web, what kind of computer is it on? It doesn't matter. Where's that computer located? I don't care. What's the operating system that computer's running? Doesn't matter. What operating system am I using? It doesn't matter. What browser? It doesn't matter. What software is serving the information? Tomcat, Glassfish, Nginx, Apache. Doesn't matter. IIS, who cares? WebSphere, it doesn't matter. We can still access it, even if we've never talked to that computer before. And how's it stored? Is it an XML file, an HTML text document? Is it data in Oracle or MySQL or DBase or MongoDB or what? It doesn't matter. How old is the software on the server? It doesn't matter. Is there something in the information I want to learn more about? Yeah, I can follow the hyperlink and get to and dig deeper and learn more about whatever I'm reading. And so in other words, it just works. The web works because we agreed on a simple set of standards. It's simple, it's scalable, and it's incredible. It's an incredible time to be alive. And in fact, we've gotten so used to having limitless information available to us at our fingertips that it's actually worth taking a step back to appreciate how truly awe-inspiring this achievement really is. But here's the thing. This vague but exciting proposal, it took a few years to get any real attention. And that was back when a directory of every single person on the internet was the size of a phone book. Yes, this book actually contains the names and addresses of every single person on the internet. Think about it. What would that look like today? Actually, never mind. I know exactly what it would look like. It would look like the internet. So if you're wondering why what I'm about to tell you is so important that you've never heard of it, the reality is it takes time for an idea to reach its tipping point. And in fact, when Sir Tim Berners-Lee presented this proposal, the reaction was kind of broadly, so what? Hypertext wasn't new. Networking wasn't new. But once the penny dropped, it exploded. And the penny is about to drop on linked data, and here's why. There's a problem shift in technology. I talked about imposter syndrome earlier, and I used to feel imposter syndrome over Stack Overflow driven development. I think that's a thing, SODD. But now I realize the truth. We've just been able to shift from working on one category of problems to harder and harder problems. Got an error message? I'm going to Bing it. Need to manage orchestration of a massive distributed system? I got Kubernetes for that. If I need a modern dynamic web UI and I don't want to spend days and weeks coding up observers and binding and everything else, I don't have to. Angular, React, Vue, take your pick. And so much complexity is abstracted away that now we get to focus on harder and harder problems. An interesting little case study was 2016, the city of Austin, Texas. If you I remember right around the time that this happened because I was actually at a No Fluff event in Austin, and Uber and Lyft had just left town. So if you don't know this backstory, basically back in 2016, Uber and Lyft were at a standoff with the city of Austin. Now, the city wanted their rideshare drivers to complete a formal city background check, very similar to what a taxi driver would have to go through. Now, Uber and Lyft, they have their own process that they thought was good enough. And to put anything on top of that would be overly burdensome, and they just didn't really want to do that. And so the city of Austin forced the issue, and Uber and Lyft called their bluff, and they left town. Overnight, there was no more Uber, no more Lyft, no more rideshare. And within 72 hours, new rideshare apps were launched and were operational. Think about that. A decade ago, it took Uber a couple of years to build their platform. Today, it takes days. Why? It's an integration problem at this point. To build an Uber clone, that's all we have to do. Take a bunch of data sources, integrate them together into an app, a backend, and that's the hard part, was the data. The application frameworks and being able to work with that was actually the easy part. And so data makes entirely new categories of solution possible. It also drives insights. In fact, this has been going on and just accelerating. Tycho Brahe spent his life documenting the positions of the stars and the planets. And although Rudolphine Tales is a somewhat dry read, it also happens to be written in Latin. It was instrumental in launching the scientific revolution. And on Tycho's heels, folks like Kepler and Galileo, they spent decades analyzing this data, identifying the patterns, and ultimately drawing important conclusions about how the universe works. And machines can find these patterns and analyze data so much faster and so much more efficiently than we can. But we can get unimaginable data value from data. And in fact, there's an entire data economy. And in fact, it's at a point where we just basically gather all of the data that we can, and we figure out how to leverage it later. And as a result, we've begun to collect a lot of data. And by a lot, I mean a lot. 3 years ago, IBM said that 90% of the data in existence was created just in the last 2 years alone at a rate of 2.5 quintillion bytes of data a day. And it's pretty safe to say that data is growing much faster than that now. And in fact, it's driven by a handful of key trends that we're getting explosion of devices, explosion of sensors, ubiquitous connections, all at the same time, while storage is what it's like 15.5 million times cheaper in my lifetime is how much cheaper storage has gotten just in my lifetime, the cost per gigabyte. And computing is really inexpensive as well. And at one point they did a study at, I think, Berkeley, and this was the early 2000s. So this was about 15 or so years ago. And they came to the conclusion that the sum total of all human knowledge was estimated to be around 11 or 12 exabytes. That's 11 or 12 quintillion bytes of data. And by now we're doing 2.5 exabytes a day. And that was 3 years ago. So it's only faster now. And in fact, the IDC predicts that by 2025, the total amount of digital data in the world will rise to 163 zettabytes. I had to look this one up because as far as familiar as I am with my SI prefixes, I had to look this one up. Zeta, I don't know how high that goes. That's 163 sextillion bytes of data, which looks like this. Or to put this in more tangible terms, if we were to store this amount of data on floppy disks, we would need 110 quadrillion floppy disks. And if we laid them end to end, the distance of that line of floppy disks would be over a light year. Almost 5.9 trillion miles. So yeah, there's a lot of data and there's a lot that we can do with it. But there's just one problem. Where is all this data? All over the place. We are back to the Wild West. You want to consume some data? Well, that means you're going to have to connect into a custom app on a server, hosting its own custom information system with its own commands and quirks and its own method of organizing the data. You need to look somewhere else? Well, start all over again by reading the API docs. So let's look at a concrete example. If I had this document and I wanted to integrate it programmatically, I would probably request a JSON document, right? So here it is. Hooray. Now, how am I going to integrate all of this? Well, first I need to parse the structure. Then I need to figure out, am I creating a record or updating a record? In other words, which Michael? And then you need to sanitize the data, right? And standardize the data, homogenize the data. So we've got 710 here. Is that July 10th or October 7th? Well, I need to read the API docs to figure that one out. And then we need to disambiguate Wyoming, because do we mean the state or any of the various other Wyomings? And what happens when we build software, we tend to be narrowly focused, and we kind of tend to be internally focused instead of expertly focused. We're focused on the now instead of the future. So I built the system so everything is obvious to me. I know which Wyoming. I know who Michael is. I know what I mean by 710, but you don't. And if you want to find out, well, you better set aside a couple hours to read the documentation. Then we need to store all this data. Do I even have all of these columns? Or do we need to start adding those and get a release in there? So ultimately, this means you want to query some of the data. Well, you better start writing some custom code. Oh, you want to integrate that data? Well, you better start writing some custom code. Oh, you want to store that data? Well, get the analysts involved, get a DBA involved, get a developer involved, spend a week or more, then repeat infinitely. This will not scale. You will never catch up. It is not possible. These two lines are not going to converge. It is simply not going to happen. Well, what are the alternatives? I was a DBA for several years. Don't hold that against me. And by the way, you do know what DBA stands for, right? Don't bother asking. There's one thing I learned in my time in that role. That would be it. But we tried to standardize and homogenize and centralize all of this data. We built an enterprise data warehouse, and we wrote all kinds of custom ETL jobs that would get it, that would parse it and format it and restructure it and put it into this nice rigid schema that worked until it didn't. And you don't see a lot of this anymore. And now we're seeing kind of a new trend, which in many ways is often the exact same movie with a new name. And we're calling it a central enterprise knowledge graph. Now, both of these are centralized, consensus-driven approaches that haven't worked in the past and are unlikely to work in the future. Now, EKGs do have an advantage. And the advantage is that they're typically graph-based, which gives them a lot more flexibility. But if you're trying to take a centralized command and control, consensus-driven approach, you're going to suffer from the same problems. Remember, by 2017, we were generating 2.5 exabytes of data a day, and it's exponentially no more now. And if we try to centralize this into one giant Neo4j cluster, you're just not going to get there. We keep creating data faster and faster and faster. So I'll say it again, you will never catch up. But here we are. We still need an alternative. And the thing is, beyond how asymmetric data production and our capacity to consume data currently is, I want you to imagine what the web would have looked like if there was just one host and they had to manually convert all of the information into their own format as it was created. What we would have today is a fragmented, infinitesimal fraction of what we actually have. There is a reason that this and this and this is nothing but a footnote in history. And these approaches weren't bad. They were a nice idea in the absence of anything better, but it's not the 1980s anymore. Consensus-driven, centralized approaches to information management have tried to kick against the gods over and over again, and consistently they fail. It is inevitable. And the web succeeded precisely because it wasn't centralized. We didn't have to put resources into the web. We left everything where it was and instead put the web into our resources, and we can do the same with data. So if we want to integrate data, ultimately there are 3 heterogeneity problems that have to be solved: syntactic heterogeneity, structural heterogeneity, and semantic heterogeneity. In other words, is the data that we want to integrate in the same format? Are the data shapes compatible? Well, I have a table here, but a jagged hierarchy over there. Is this going to work? And do we know formats? That's strange. Okay. Interesting. We have common serialization formats that solve number 1. And knowledge graphs use graphs as a data structure to solve number 2. And it's a good approach because graphs are very flexible data structures. The challenge here is the semantics, because typically a centralized EKG generally prescribes a global ontology for all the known data attributes, which becomes extremely limited. And even if you end up prescribing multiple ontologies, again, the consensus-driven approaches generally fail. And that's where the semantics come in, is what do we call things? But all 3 of these have been solved with a single standard. So how do we get there? Well, first we need a flexible data model. Now, data exists in a lot of different formats. So we need to be able to find a structural heterogeneity, and we can translate tables or documents into graphs. So if we start to break our data and its attributes down into nodes of a graph, well, we've got some possibilities. But the cool thing is, however we currently store the data, we can leave it where it is. These standards don't require us to migrate to some other platform or anything else. We leave it where it is. We just have to be able to represent it in a consistent way. And we can convert all of these basically into name value pairs. And a name value pair is fundamentally the smallest irreducible unit of data. And so if we were to decompose this into name value pairs, we might get something that looks like this. Now, we still have some challenges to deal with. And the first one is identity. Well, 6995 might mean something in the context of my people table in an internal database, but that doesn't map to anything else anywhere at all. So we need a universal identifier outside of my little fiefdom. We solved that decades ago. It turns out universal identity has been around for at least 30 years. And the system works so well that we don't even think about it, right? We exchange these kind of identifiers between machines, between technical and non-technical people. It just works. And there can never be a collision because I control my namespace. And I don't have to change my primary key in my database. I just add some context to make it a universal identity. And since I own this resource, I can name it whatever I want as long as it's a stable name. Now, it does get tricky, though, because I don't belong to the example.com organization. I belong to me. And this URI might give you a document about me, but I want an identifier that is me. And we can do that. So if I have a document about me on the example.com domain, I can link it to w3id.org, and yes, that's a URL, but yes, that is me. We can assign these types of names to anything, information resources, or what they call non-information resources, in other words, things. So this becomes my identity. There are many like it, but this one is mine. So great, now we're clear on who I am. And we know now that given this context, we have many name value pairs that are unambiguously talking about me because we're using a standard structure. So the next challenge, what do I mean when I say birth date or birthday or B-day or DOB or birthday time or whatever you want to call it? So we need a standard vocabulary. And these already exist in all kinds of domains, people, organizations, industries, pizza, right? You name it. And as you dive into this topic, you're going to see there are a ton of vocabularies ready and waiting for all of us to use them. And if they don't exist, we can create them, we can extend them, we can discover them programmatically and map them to other vocabularies. Now, every term in that vocabulary becomes just another unambiguous name. How do we make it unambiguous? The same way we make 6995 unambiguous. We can call the field whatever we want as long as we include that URI in the link. In other words, we keep linking the data. So this right here, this thing that I'm calling birth date is schema.org/birthdate. It doesn't matter what I call it as long as somewhere my data communicates that by DOB, I mean schema.org/birthdate. This tells me not only what the field means, but how to interpret the value. And if I've never seen that term before, I can follow the hyperlink. If other ontologies, other vocabularies call it different things, I can discover those mappings as well programmatically. So now we have a way to unambiguously represent any conceivable single fact. Now we're starting to extend just a little beyond name value pairs, but not very far. Ultimately, we're extending them to become self-contained facts. Michael is from Wyoming. Michael's birthday is July 10th. And instead of 2 parts, we'll really have 3. I mean, there can be more, but this is pretty common. It's called a triple. Each triple communicates a single fact. It's a single line. And we have a subject, which is me, a relationship, and a value. And the terms that we typically use is subject, predicate, and object. So we can kind of emphasize this like this: the subject, the relationship, and the value. And so if we were to kind of store these statements in a SQL table, well, we have a row that's about me, a column name of birthplace, and a cell field of Wyoming. So each statement is basically its own cell in a table. It gets broken into these 3 parts, and that's why we typically call these triples: the subject, the predicate, and the object. And the object can be a literal, or the object can be another link, and that we keep discovering more data and keep connecting more things. So by adding in the links, clients now can answer all kinds of questions by themselves. So the links really solve 3 problems. We get extra information. What is Michael? Well, it's the same Michael that we're talking about here, the same Michael that we're talking about there. If I don't know, I can follow the link to Michael and find out more about me. They remove ambiguity. Now I know exactly which Wyoming we're talking about. And they add standardization, because birth date is not just a term in a vocabulary, an ontology that is defined by schema.org. It also is in itself standardized, which means I know exactly what notation we're using. So these 3 characteristics make the linked data more reusable. So think of triples essentially as name value pairs on steroids with 3 parts instead of 2. Now we can serialize one of these facts like this, and this is actually in the N triple serialization format. There's a lot of different serialization formats. This is but one. And we just use the links. w3id.org/people/rmichaelcarey. Schema.org/birthdate is 1982-710. In other words, the subject, the predicate, and the object can be represented a whole lot of ways. The angle brackets indicate that they're URIs, or I guess technically IRIs, but the quote symbols indicate literal values. You can format these several ways. This is another serialization format. This one's called Turtle. It's the terse RDF. Every time I try to define this, I draw a blank for some stupid reason. But it's just another way to represent the data. And it doesn't matter what serialization format you use. Because you can use JSON LD, you can use RDF XML, you can use RDF star, you can use Turtle, you can use N triples. There's a ton of these serialization formats. But what's incredible now is we're not constrained to just one ontology anymore. We can use as many as we want, and we can continue to add and follow links and programmatically discover more and enrich our data. So we don't have to get consensus on one global ontology to rule them all. So we could follow the links that we created according to the linked data principles and discover new ontologies and map them to the ones that we have in our application. And there are also ontology alignment techniques, and a lot of these can be done programmatically, which is insanely cool, but more on that in a moment. So what we're really talking about is breaking down data into the smallest irreducible granularity of facts is the foundation of RDF, the Resource Description Framework. We break our data down into atomic units that are self-contained and self-explanatory. As a result, every single fact is just a fragment of a graph, and it's trivially easy to connect them. So if I have one data source that has birth date and another that has birthplace, any tool, any library, any code that understands these concepts and implements the standards will be able to snap them together automatically, like Lego bricks. But let's look at something a little more meaningful. Maybe you need to integrate these 3 separate JSON docs from 3 separate APIs. So think about this for a moment. What would you do with these 3 documents? How much code would you write to merge these? None of the names overlap, right? None of the syntactically, none of the formats, or semantically, none of the formats are the same. So what would this graph look like? How would you even know these documents are about the same person? And if you don't control the data sources, you have to spend a lot of time reading documentation, write a ton of custom code, and ultimately fall back on flaky rules, heuristics, and a lot of custom logic. Or I can give these 3 JSON documents to any standards compliant parsing tool or library and get this without coming to consensus. This is it. 3 different JSON documents, 3 different naming conventions, 1 cohesive graph about me. No redundancy, no ambiguity, no custom code. How is it possible to automatically get this graph from this? Like, you might be thinking, well, this isn't RDF. These aren't linked data triples. Are you sure? Because this is nothing new. You might have had this capacity or capability for years and just didn't know it. Because JSON is just fundamentally decontextualized name value pairs. But maybe this isn't just JSON. Maybe when you ask for example.com/people/Michael, in the response header, you have this. A mapping between your JSON names and whatever vocabulary you're using, effectively turning your JSON into RDF. In 2010, the W3C began working on an expansion of JSON to include linked data, and the result is something called JSON LD. 2010. And JSON LD is designed around the concept of a context to give some additional mappings from JSON to an RDF model. So this could have been part of your JSON APIs for years that you're consuming, and you just didn't yet have eyes to see and ears to hear. And maybe this doesn't exist for an API that you consume, and it doesn't mean you can't take advantage of these things right now. In fact, I can write and inject my own context and hand it to any standards compliant tool or library. You just embed the context yourself. And sometimes the context is actually embedded in the documents. Other times it is in the header. There are a lot of different ways to present this. People like to do this type of thing because it is fully backwards compatible and is never going to break a parser, but you can also take advantage of all these forward-looking things. So if you're building something new, then you can give first-class support for linked data and RDF and JSON LD. You define your context here, define a few prefixes, and then instead of just calling it name, I say schema.name. And we've already defined that prefix up here. So now we know that anything up here is schema.org, and there should not be a trailing slash there. That is my mistake. But I don't. It doesn't matter. But it's not idiomatic to have that slash there. So I can just use naming conventions directly from the ontology or ontologies that I've chosen. So we've got prefixes in the field names. You can also just map them in the context like we did here, saying when I say DOB, I mean schema.org/birthdate. And some amazing things happen. So what happens if you're taking the standards rather than the hard-coded literal-based parsing? What happens if one of these columns changes? It doesn't matter, because we can just realign the semantic labels. What happens if I add a field here? It doesn't matter. And in fact, my software knows exactly what to do with it, exactly what this new field is, and exactly what to do with it. I don't care at all. Our graphs just get bigger. And I hope you see the potential of just this piece and how it's trivially easy to add this capability to APIs that you own or APIs that you merely consume. And if not, I want to go back to the robots for a second. Because yes, now we have robots that clean up behind us. We have robots that mow our lawns. And what's interesting is, like, this was some Jetsons future craziness when I was a kid, and now it's a trivially easy problem to solve. What's more interesting is these robots. So for the longest time, and I'm going to try to be courteous, and I'm going to use the official title and not the wake word, which is the unofficial title. I'm going to talk about my Echo. For the longest time, my Echo was just a lazy jukebox and a weather vane. Like, that's all I ever asked. Is it cold outside? And play some music. That's literally it. I know you're thinking about it. But now I ask my Echo really specific questions. My wife was looking very, she was scheming over by the Echo right now. Mischievous. Yes, thank you. That was the word I was looking for. But no, now I ask my Echo very, very specific questions. And increasingly, it knows how to answer them. Like, this is just a snapshot. These are actual questions that I have asked of my Echo in the last 30 days that just happen to be in there. And don't judge me by the things that I ask my Echo. But let's think about how you would build this. There are three big challenges. Number one, speech transcription. Number two, natural language processing to figure out what to do with the transcribed request. And number three is knowing the answers. Now, today, 1 and 2 are commodities, right? Cloud services are out there. Off-the-shelf libraries are ready and available. Number 3 is the hard part. Now, it's just not feasible for a team of developers at Amazon to be writing custom integrations to increase the Echo's knowledge every day. It's also not necessary because an Echo can find and report these facts all on its own. And in theory, they could have set up, actually, before I say that, and in fact, all of these kind of smart assistants are built on these ideas. What we know as Siri started as a semantic web technology company that were experimenting with exactly this, leveraging open link data, discovering and integrating it programmatically to learn all of these different things. If you remember years ago, Watson, IBM's AI that went on Jeopardy and played Ken Jennings, the like reigning super champion, and mopped the floor with him. Well, Watson did the exact same thing. And in fact, they're the exact same data source we're going to talk about, because in theory, one of the things Amazon could have done was set up a massive, just phenomenal cluster of machines to decompose a free information store like Wikipedia at great expense over a period of years to build a giant centralized knowledge graph, but they didn't have to. Volunteers already did this. They said, hey, this information is great, but we want to operationalize the data in ways that don't require a human in the middle to parse it or try to do all kinds of convoluted natural language processing every time we wanted to learn something from a Wikipedia article. And so they started decomposing these articles into facts. And in fact, DBpedia contains now about 9.5 billion facts and counting. And this was almost 15 years ago. Now, in 2007, other folks saw the potential of this. They saw the potential of the revolution, and they started publishing their data in these formats as well and linking to DBpedia. And DBpedia was linking to them to enrich their data sources. And thus began the Linked Open Data Project. This is 2007. Within a few months, we had several more data sets that started to embrace the standard. And it got bigger, and it got bigger, and it got bigger. And these data sources can now be integrated almost as fast as they come online. And this is just public data. So let's look at some of these questions. I just randomly asked my Echo to settle a discussion. Who is the lead singer of Hootie and the Blowfish? And apparently it's Darius Rucker. I did not know that, but my Echo did, and Siri did as well. Now, obviously, this could have been satisfied with just the public link data that we had back in 2007. We had DBpedia, and then one of the already integrated music data sets would work. But Amazon isn't just integrating external data sources. They're taking all the data they have internally and projecting it into machine consumable formats so that we can further increase what these things know. I asked how long cooked bacon was, and they took a customer's answer and projected into a format that the Echo could ingest, and now all of that is available to the masses. They're embracing these standards to operationalize their own data, reviews, question and answers, pictures, ratings, sales figures, linking these data sets. So obviously Amazon is embracing these ideas and rapidly building innovative new products as a result. But who else? A lot of folks. Now, as cool as all of this is, it doesn't mean we want to blindly integrate everything. Like any standard, they're going to be open to abuse. You've probably seen this floating around as a meme, as a joke. And in fact, this is a screenshot from an article about this joke that is floating around, that people have managed to convince Google that running was invented in 1612 by Thomas Running when he tried to walk twice at the same time. And it's funny, I was just looking for this graphic because I knew it was out there. So I did a quick Bing search, who invented running, to find the graphic. And right up in the answers, it says, oh, that was Thomas Running invented running. And so the good news is, not only are all of these concepts not new, but they're well established and mature. And in fact, you don't have to blindly trust everything. You can define constraints. You can look at provenance chains or cryptographic signatures, because all of this is just more metadata. And so we can lock down with certain trusted digital signatures or other kind of quality gates. And you have tools like Shackle and you have tools like Sparkle to find things that match patterns and to exclude things that don't match patterns. And so you can put your trust into where the data comes from as a gateway towards operationalizing that data. Although, interestingly enough, if you ask an Echo, you do get the real answer. And that's the key thing, is when you're going down this road, that when you're going down this road, you can choose what data you trust. But where are we with linked data? Well, linked data is absolutely everywhere. And you're seeing it, you're benefiting from it without even realizing it. I think it's about 48% of all indexed web pages now have embedded linked data. Increasingly, emails have embedded linked data. And this is a really cool example, that when I get the flight information from the airline, they embed, using these principles, a series of facts about a flight. And Google then is able to pull all this out and then link to other data sources and bring in, oh, my flights, I have a gate now, I have a terminal, my flight is on time. So I got real-time information and even where to check in. And so we got linked data embedded in emails, and email clients are enriching that with other linked data sources, and they create dynamic and useful views. And in fact, search engines do this all the time as well. All of these kind of cool extra search results, in addition to the pages, this is just published linked data that's being used to enrich search results. So increasingly, systems are dynamically integrating new linked data sets. And you're probably wondering, well, if folks aren't sucking all of this data into a giant Neo4j cluster, and folks aren't employing tens of thousands of developers to write and maintain new API clients to use the data, then how can this possibly work? And the answer is the same way the web does. I could go to any web server, whether I've talked to them before or not, and make a request. And if I am so authorized, then I will get a response. And we've taken something massively complex like the web and distilled it down into a handful of standard protocols and ultimately just a couple of commands. I have a way now. I can ask a web server that I've never spoken to if it knows anything about a resource. And it responds with a 3-digit code. 200, yep, I've got that. 404, I don't know what you're talking about. 403, you're not allowed to ask that. 401, who are you? Right, it's a simple verb, a name, and a response code. And we can do the same kind of thing with data from a server that we've never talked to before, from an API that we've never talked to before. In the same way, I can ask questions of these data sources. I can just say, hey, do you have anything called Wyoming? Now, this is a really trivial example, and I've got a more comprehensive example in a moment. But I can just ask the data source, do you have anything that's called Wyoming? And it'll just come back true or false. So this becomes a very simple gateway to start digging. Well, give me all the resources that have any object of Wyoming, or specifically have a name of Wyoming. And then I can define a graph pattern. Well, I want anything that has a name of Wyoming that matches this graph pattern. And I can select out what facts it has about a given subject. I can do this even if the data source uses an entirely different vocabulary from mine. And this is where we get onto another standard. Because so far, I've mainly talked about some of the concepts, some of the history, and JSON LD. And JSON LD solves one part of the puzzle. It's an RDF serialization format. It makes integration easy. But integration is great, but if you don't know what if you don't know what you know, and you don't know what you don't know, and how to find what you don't know, then this is a hard sentence to parse. If you don't know what you know, and how to find what you don't, and how to learn new things from existing data, then there's going to be a ceiling on the potential of what you can do with linked data. So to ask questions, we need a query language. And Sparkle is that query language. And, you know, when I was a DBA, if I wanted to dig around the data and discover something, people would say, hey, here's our REST API. And I'm like, yeah, cool. Okay, REST API, great. Thank you. I'm going to connect to the database and hopefully not screw anything up. But that was where the power was. With an API, it's like, okay, fetch me this entire collection. Oh, I can only get 20 at a time. Okay, 20. Okay, I've got all of this. Now I need this. Now I want to do some kind of join. I want to do some kind of logic. I want to find intersections and change the shape of this and do cool new things with it. And you can't do that with the REST API. You can just get resources and collections of resources, bring them down, and do your manipulation there. But Sparkle is not just a query language, but Sparkle is one of those recursive acronyms that stands for Sparkle Protocol and RDF Query Language. So very strange. That was odd. So basically, this is a semantic query language for querying RDF datasets, and it gives me the ability to retrieve and manipulate datasets that are stored or projected into the RDF format. I can do graph sub-abstraction. I can combine graphs. But what's really cool is I can push graphs to the server as well. So there's a couple kind of key components about Sparkle. It's graph oriented. So instead of just giving a where clause with where x equals y or whatever, whatever clauses you want to throw into that query, you give it a graph pattern. Now, graph patterns can be simple, they can be complex, they can be enormously complex. But what's really cool is you can also combine multiple discrete, disconnected data sources and push these queries out and let the protocol do sort of a scatter gather kind of thing here. So for example, and I can also do semantic inference, which is really wild. So if I know that Michael is example.com/people/id/6995 in my world and something unknown elsewhere, I can actually infer relationships programmatically based on graph patterns. Maybe just using my email, knowing that that emails are usually tied to an individual. So if I take what I know of Michael and his email addresses and find anything else that uses those email addresses, I can suddenly start to plug these things together effortlessly. And that's really wild. So it's graph oriented. The queries fall into a different category. Select is where you give it a graph pattern and you pull out a graph pattern, you get a result set out. Ask is another one. You can just ask the data source, do you have anything that matches this graph pattern? And again, it can be simple or it can be complex. It's just a short way to say, hey, do you have any information that looks like this? And if the answer is yes, I might be interested in you as a data source. And remember, because we don't have to write any custom software at all, this doesn't have to be a big, complicated effort. I could do this all day long. Hey, do you know anything about X? Again and again and again. And if the answer is yes, so tell me what you know about X. The next one is enormously powerful. In addition just to matching patterns, we can create entirely new graphs based on what we already know. And this returns a graph. And this is where we get into semantic inference and semantic reasoning. And another thing we can do is we can just say describe. So in addition to all the above here, I can just say, tell me what you know, and I'll get back a graph. And I as a human or my software can follow that graph and follow the nodes and follow the links and keep discovering more and more and more without having to throw out a lot of effort. And in fact, I mean, Sparkle's enormously powerful, and it's a single uniform API standard that allows us to do all this. One single endpoint. I can query graphs and subgraphs and discover new data sources and integrate them and even infer all of these new relationships from our existing data in a unified standard way. There's a lot of power in there, and there's a lot of capability. This is a fabulous book. If you want to dive deeper into that, this is Bob Ducharme's Learning Sparkle, and I think I have the second edition, but which I think is the current edition. And I need to wrap up, but I want to throw out just a couple more points. We've talked about the standards. We talked for the data model. We've talked about the standards to query and manipulate and explore the data. Now, the key thing is, I don't have to move my data to start taking advantage of this stuff. I don't have to take things out of SQL Server or Oracle or MySQL or Postgres or whatever. I can take that existing data and project that on top. In fact, one of the cool things about these being mature standards is there's a lot of tooling out there. And the name is escaping me. I want to say a D2IQ is formerly Mesos. R2DQ, RQD2. I think it's RQD2 is as a Java package that will basically take a relational database of your preferred flavor and project that into RDF and expose a Sparkle endpoint available to you. And you can do that in moments. I mean, it's something that I could do in a demo here in 2 minutes if we had more time. But so we don't have to move our data to take advantage of this. And we don't have to change our API. I can have a REST API and a Sparkle endpoint. There's no reason why you can't do both. And in fact, a good first step is to start to enrich your existing REST APIs. Because we've talked about the standards, we've talked about the standards to query, and we want to talk about how to reuse data across domains, but how do you get there? Like I said, we don't need to change the tools. We don't need to reinvent the wheel. We just take a single resource and wrap it in an API that's forward-looking. And by forward-looking, I mean a couple of things. It has stable identifiers, that the name of the resource, the identity of the resource, doesn't change when your API version changes. Right? That's an unstable name versus a stable name. It supports content negotiation, basically level 2 on the REST maturity model. And then you've got to be able to connect resources to other resources. And what's cool is the connections can be captured and stored, or they can be generated on the fly. And we don't need to co-locate the data and the linkage unless we want to. And we can build our own link sets, or we can discover link sets on the edge. But the key thing is to do this incrementally and to stay with your preferred technologies. And the kind of core principles. Use URIs as names for things, stable URIs as names for things. Use HTTP URIs because there are a lot of different types of URI. A URL is a type of URI. A URN is as well, but a URN is not resolvable, and a URL is. So use HTTP URIs. They're resolvable. That way, people can actually look up those names. And whenever somebody looks up a URI, provide some kind of useful information. So if you go to schema.org/people/birthdate, it's going to, if you take a point a browser to that, you're going to get the documentation about it. If you point a linked data client to that, you're going to get key information about that ontology. So when somebody looks up a URI, provide useful information. And include links to other URIs, to other resources to facilitate finding more data. Now, I want to wrap this up. So I want to leave you with kind of a case study where you can actually see some of the power of this. This case study comes from a paper published in Briefings in Bioinformatics. And what this really is it's about accelerating what we can build today in the same way information accelerated what we've built over the last 25 years. Being able to show our customers things that they couldn't otherwise discover. Ultimately unlocking the full potential of data and getting a benefit on the scale that we got with information on the web. And so this paper started with PubMed. PubMed is a journal for biomedical literature. And there are the answers to important questions. There are key insights and discoveries that are locked inside of tens of millions of research papers. Papers that were written for humans and not machines, which means if you want to get them into a machine, they basically have to go through a human or a poor simulation of a human. And researchers realized that despite the explosion of information, they were starving for valuable data. They were hitting a ceiling. And in fact, the authors put it this way. Instead of ushering in a new era of biomedical insight, the growing abundance of data on the web has intensified the need to develop new approaches to manage and integrate it. If we fail to do so, knowledge will remain fractured, encoded in a myriad of representational dialects, and effectively inaccessible to the majority of researchers. So step one was document decomposition. Step two was enriching the data they already had by linking additional data sets. And that was easy because RDF solves a lot of data integration problems. And the result was a startlingly powerful way to leverage the data that they already had. They took the data that they had in whatever sources it was in, they projected this into RDF, and they exposed a Sparkle endpoint. And suddenly they could discover in hours what used to take weeks. They put this together and they wanted to try something. Very simply, what they wanted to try was to ask a very real and very specific question of this data. The scenario that they thought up was a researcher looking for novel treatments to Alzheimer's. And it started with an observation that Alzheimer's patients show particularly damaged, a particular set of neurons is often very damaged in Alzheimer's patients. These are pyramidal neurons. And okay, well, what do pyramidal neurons do? Well, they do several things, but one of them is they're very important in the signal transduction process, which is interesting because signal transduction is very druggable. In other words, it's very easy to kind of make things happen with existing drugs. So what they wanted to ask is, instead of spending weeks or months or even spending the time it takes to write an entire PhD thesis on studying these things, studying all these articles to try to tease out what they could find, they asked a question. They said, of the data to a standard endpoint using a standard query language, what are the signal transduction processes in the human body that are controlled by pyramidal neurons, and what are the genes that control those? If you asked even a very good semantic index of the PubMed journal, you would get thousands of hits and 0 results. When they asked the data in RDF, they got 40 hits and 40 results. It didn't require a special API, a custom data set, an ETL job, custom code. Just a query to a standards compliant API endpoint that was fronting standards compliant data. The results were immediate and real data, actionable data. And so by leveraging the linked data principles and the standards, they transformed journal articles into standardized data ready to answer questions as quickly as we think of them. And I just want you to take a moment. All the amazing things that we can do today because we can access information and get answers and get information that answers our questions as quickly as we can think of them right now. Just imagine for a moment what is possible when we can do that consistently with our data. And it doesn't mean we have to make all of our data open, just in the same way everything we publish on the web isn't open. There is open linked data. And in fact, that cloud that I showed you was this cloud somewhere is a cloud of open linked data sources. Not everything has to be open linked data. And maybe you don't want to trust everything that you find. Maybe you want to use curated data or anything else. But we're at a point where the problems that we were solving are shifting. And in the same way that in a matter of years, we have robots at our beck and call, I can ask anybody on the world a programming question and get an answer in minutes or immediately. what we can do with the data. And so this paper was published almost 12 years ago. And what I find is when people talk about the semantic web, the result is, well, I guess that's kind of cool, but I don't get it. In the same way, 30 years ago, when we were talking about the web, most of the world's response was, that seems kind of cool, but I don't get it. And then all of this happened. And when people talk about the semantic web, they say, yeah, we're still waiting for that. No, this was almost 12 years ago. We're not waiting for it. We're there. And this is insanely powerful. It's going to change the world. And these are standards that if we can ignore at our peril. Thank you.
Thank you, Michael. And thank you for everybody who's watching tonight or the replay sometime in the future. So for our guests tonight, make sure you leave a comment with your preference of the door prizes. We will be contacting you through the meetup messaging, so make sure you've got that so you see those messages if you get those. Thank you for Michael for tonight's presentation. Very interesting, consumable, and helpful. So I appreciate it.
It's always a pleasure to be here. Thank you for having me as always. Definitely.
So future events for DOSUD, we'll be skipping a holiday party for hopefully obvious reasons. What else we got? I think that's about all we have, except, if you haven't voted by now, probably ought to get out there. Appreciate you coming out or staying in, as it were. And we will see you around. And consider speaking or even helping us out sometime. Drop me a line. Appreciate it. Thank you.